Good morning student, welcome in KTHF College, Nasik and Department of Chemistry. Myself, V.S. Shinde. Student, in previous lecture we have seen trans effect, after that theories of trans effect and series of trans effect. So, trans effect is basically observed in square planar complexes and it is defined as labilization of ligand that are trans to certain another ligand is called as trans effect. Okay student, so let's see the series of trans effect. This is the series of trans effect which is made based on combination of theories. That two theories are polarization theory and pi bonding theory. Okay, these are the pi acids or pi bonding ligands Cn minus CO, NO, C2, H4, which is at the highest position in trans directing series. Okay, these are at higher trans effect and these ligands having lower trans effect. And this series is made based on that both theories, polarization theory and pi bonding theory. Okay, and in today's lecture we will discuss some problems based on trans effect, and that problems is very important for your examination. Okay, so let's start. Let's see first problem, that is a synthesis of cis isomer by using PtCl4 2 minus. Okay, we have to synthesize cis isomer by using PtCl4 2 minus square planar complex. So let's start. Pt, Cl, and Cl 2 minus. If we treat NH3 with this complex, obviously among these 4 chlorine, 1 chlorine will replace, and instead of that chlorine, NH3 will place. Minus. Okay. What happened here? This is our starting substrate, that is PtCl4 2 minus. We have to treat this NH3 with this complex. After treating NH3 with this complex, one of chlorine get replaced and NH3 get placed at that chlorine. Okay. Again, if we treat NH3 with this complex, that is PtCl3 NH3, we will get cis isomer. What we get? Cis isomer. Why cis isomer? Now, question is that why NH3 means here is NH3 and chlorine is exactly trans to this ammonia or NH3. Why this chlorine not replaced? And why only this chlorine is replaced? Because of trans-directing effect of this chlorine, because chlorine possesses higher trans effect than NH3. So this NH3 is unable to replace this chlorine. So one of from this both chlorine, one of chlorine get replaced and NH3 is placed at cis to this NH3. So we get cis isomer. Have you understood? What happened if this is the complex PtCl4 2 minus? If we treat NH3 with this complex, any chlorine get replaced and instead of that chlorine NH3 is placed. When again we treat NH3 with this complex, we will get cis isomer because Cl has more trans-directing effect, or we can say NH3 has less trans-directing effect as compared to Cl. So we get cis isomer. Okay, let's see trans isomer. Means synthesis of trans isomer synthesis of trans isomer by PT NH3 4 2 plus. Okay, we have to synthesize trans isomer now by using PT NH3 4 2 plus. Let's see. PT NH3 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 and NH3. Plus 2. When we treat Cl on this complex or with this complex, we will get PT Cl NH3 NH3 and NH3. Means any one NH3 get replaced and instead of that NH3 Cl is placed. Okay. When we again treat Cl with PT NH3 thrice Cl plus, we get now here we get trans isomer. Why this is so? Because in second step, what happened here? One of NH3 get replaced by this chlorine and see its trans position. Cl NH3 opposite to Cl NH3 is there. Obviously NH3 has less trans directing effect, so Cl can easily replace this NH3 and next Cl is place that position or acquire that position. So we get here trans isomer. Okay, so for cis isomer, less trans directing effect is required, and for trans isomer, more trans directing effect is required. Okay, so let's see another problems. Just we have seen synthesis of cis isomer and trans isomer. So let's see another problems. Sometimes question may ask like this. Sorry. Okay. In your examination, sometimes may ask question like this. So you have to solve this, and this is very easiest problem based on transequent. So PT NH3 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 NH3. When we treat NO2 with this complex, obviously one of NH3 get replaced by this NO. So PT NO2 NH3 NH3 and NH3. And next, if we treat C, that is carbamide. Now see where which position replaced by carbamide. So let's see trans-directing effect of NO2 and NH3. Here is your NH3 and here is your NO2. So obviously NO2 has more trans-directing effect as compared to NH3. So obviously its trans position or its trans NH3 get replaced by CO. NH3, CO and NH3. Again, here trans isomer is okay. This is another problem. Again, we will see some problems. So student, this is another problem. problem, and that problem may ask in your competitive exam. So PTCL L PR3 PR3 on treatment on treatment of pyridine with this complex, we get PT pyridine L PR3 PR3 means pyridine replace this chlorine and acquire that position. Okay, so you have to think the trans-directing power of ligands. L is nothing but all these ligands, NO2 minus, Cl minus, pH minus and H minus. Okay, so let's see which has more trans-directing effect, so your reaction get proceed faster. Okay, so let's see NO2. Here is your NO2. After that Cl minus. Here is Cl. Next pH. Here is your pH and H minus. Here is your H. Okay, so H minus has more trans-directing effect. Then next to H, pH is there. pH minus. After that NO2 is there. NO2 minus. And last, obviously, Cl is there. Cl is there. So, H minus, pH minus, NO2 minus and Cl minus. Where is that option? H minus, pH minus, NO2 minus and Cl minus. This is nothing but your answer. So, this is the directing power of your ligand. So, your reaction proceed faster. Okay, this type of questions may ask in your competitive exam like NEET, SET and GATE also. So let's see another problem. PT, CO, 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 CO. When we treat I with this complex and treatment of OH with this complex. PT, CO, 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 CO. CO is nothing but carbonyl. When we treat I with this complex, one of carbonyl gets replaced with this I. C. One of CO get replaced with this I. So, after treatment of OH, now let's see the trans-directing power of iodine. This iodine is here and CO is here. So, obviously CO has more trans-directing power because of its pi acid nature as compared to I. So I is unable to replace its trans ligand. So obviously OH is placed at this position or at cis position. So we get here cis isomer. Okay, we get here cis isomer. PT, I, OH, CO, CO, cis isomer. I and OH are placed at its cis position, so we get cis isomer. Let's see another problem. PT, H2O, 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 H2O. When we treat NO with this complex, obviously we get any H2O get replaced by this NO, so we get such type of isomer. And if Br is there, so what happened? See trans-directing power of NO. So NO is again at higher in trans-directing series because of its pi acid nature. So this NO get easily replace this water and Br is placed opposite to NO. So we get here trans isomer. isomer because NO has more transdirecting effect or more transdirecting power as compared to its opposite ligand, that is H2O. So student, I think for today's lecture these problems are more than sufficient. You have to study this problem, and in next lecture we will take Google Meet, live Google Meet, and in that live Google Meet we will solve again some problems. Okay, so I can clear your doubts whatever regarding with trans effect and trans series, also these problems. Okay student, so thank you.